All right, continuing along with my examples then. So I know that my resultant for this question will be 2u plus 3v minus 4w. So remember this one off the page previous in the geometric method. You don't have to worry about it going off the page anymore because I know that 2u plus 3v minus 4w will give me my resultant. I know that 2u is equal to 2 times the u vector, 3 times the v vector, and this is going to be 4 times the w vector. So now I just got to figure out or break down u, v, and w. So u, here's my starting point. What would the coordinates be here? It would be 0, negative 3. So it would be 0i minus 3j. For the v vector, starting point, end point, coordinates 1, 1. So it would be 1i plus 1j. W vector, here's the origin. What's the coordinates? 1, negative 2. So 1i minus 2j. Now we just got to be careful here with the distribution. And this is where a lot of mistakes are made. So I'm just going to, in green, just mark down what they're going to be. So 0, this is going to be negative 6. Distributing in the 3, I'm going to have a 3 and a 3. Distribute the 4 in. And you don't have to do this. People do it on the calculator. I just do this, so now I'm just adding the green numbers. I don't have to do multiple calculations in my head. So I just got to use my signs now. All right, this tells me what to do with those green numbers I just drew up. So I have 0 plus 3, so I'm just looking at my green ones. So that's 3, take away 4, so that's negative 1i. Okay, so we start with negative 6 plus 3, which would be negative 3, minus negative 8. So I've got to be careful here. So negative 3 minus 8, that's going to give you negative 11j. That would have went off the page probably. You'd be frustrated because you'd be erasing, drawing, redrawing, etc., etc. Here we're done. What's the magnitude of the resultant? You don't have to worry about negative numbers because we square them. So 1 squared plus 11 squared is the square root of 122. All right. So I know that it's going to be 122, square root of 122 units. So those negative 1 and negative 11, when you square it, it becomes positive. Theta, it's the tan inverse of y over x, the y component over the x. So that would be tan inverse of 11 over 1. Again, the signs don't matter because I already know the direction it's going to be pointing, and I'll show you again how that works. So 11 shift tan, so I get 80, let's call it 85 degrees. Okay, so therefore, resultant is the square root of 122 units, and the direction would be, it's negative, so that means we started heading west, negative, so that means the 85 degrees is to the south. All right, if you were to draw this, say this was my origin, I went over 1, down 11, so that means you headed west, and then you headed south. And that's how that works. Finished. Okay, if you think back to how long it took before, okay, there is a bit of a time difference. This is where you really gain on time, okay? Even though you think it's going to be more complicated, it's actually not. We don't have to touch these vectors. I don't have to redraw these vectors, okay? It is simply the resultant is u plus v. Guess what? Same process. I'm just going to draw the stacked vectors. U plus v is going to give me my resultant. I'm going to extend this line out. What is the equation for a vector when we don't have a grid? So just down here, this should be on your cheat sheet. U vector is equal to magnitude of u cos theta I plus magnitude of v sine theta j. All right, there's the formula right there. So coming back, magnitude of u is 150. And if I think of it as an xy coordinate, both coordinates are going to be positive. So 150 cos 30i plus 150 sine 30 j. So that's what the u vector is. The v vector, if I start here, and my coordinate here, I'll have a negative x and a positive y. So that means I'm going to have negative 70, because the x component would be negative. Negative 70 cos 50, that's in the I direction, plus 70 sine 50 j. There you go. Now you just have to do the column addition and subtraction here. So you just got to plug that into the calculator to get your I component. You got to plug that into the calculator to get your j component. I'm going to pause it. Well, you won't even know the difference, but I'm going to stop it to do the calculations to save some time. Okay, so I got 85i plus 129j just using the calculator. So you're just adding down the columns. So I just use bracket 150 cos 30 bracket minus bracket 70 cos 50, and that's how I got my 85. Now it's the same process. Your resultant is the square root of 85 squared plus 129 squared. All right, so figuring that out, 85 squared plus 129 squared equals, and square root, so 154.5, 154.5, and it'll be in meters in this case because it actually gave us units. Tan inverse y component over x component. So I'm bringing up the calculator again. Inverse, oops, not with this one. So I've got to do bracket 129 divided by 85 inverse tan, and I get, say, 57 degrees. So there you go. The resultant is 154.5 meters. The direction, 85 is positive, so I'm going to head east. The angle was 57 degrees. The y component is positive, so then I would head north. And there is the algebraic vector. So I'm sure if you flip back and compare the two, much quicker method for sure. So one final example here, u minus v. So we know that it's going to be the u vector minus the v vector is going to give us our resultant. So at this point, you just got to determine the end coordinates as being positive or negative. So both x and y components are going to be positive. So for my u vector, magnitude of the vector, 10 cos 50i plus 10 sine 50j. All right, the v vector, it will be positive in the x but negative in the y. So that means I will have 8 cos 20. Oops. 8 cos 20i minus 8 sine 20. Okay. And now we're just going to use the calculator here to do the calculations. And again, I'll pause it so you don't have to suffer through the agony of me trying to use a calculator. So I got the x component. Remember, we're doing subtraction here. So if you're trying to replicate this on your own calculator, remember it was subtraction this time. I got negative 1.1i, and then the other one's plus 10.4j. 10.4. Okay, so magnitude of the resultant, 1.1 squared plus 10.4 squared. So 1.1 squared plus the 10.4 squared, and 0.5, so I get 10.5, let's call it, and it's in units. The angle, tan inverse, again, we don't have to worry about positives and negatives because we already know the direction it's heading. So that's equal to, pulling up the calculator, 10.4 divided by 1.1 inverse tan, 84 degrees. So therefore, your resultant is 10.5 units in the direction I component's negative, so that means I'm heading west. 84 degrees is always the angle I want. Positive, so you are heading north. So that would mean the vector is pointing in that direction. All right, so there we are. That is the lesson on algebraic vectors. So hopefully you're finding it is a little bit more efficient and a little quicker as you go through it. All right, so I'll leave the video there. If you have any questions with the homework, let me know, and we'll talk our way through it. Good luck.